Lesson 33, Demo. In this class, we use calculus to understand the behavior of a family of functions, and we find a member of a family with specified properties. A formula such as f of x equals ax squared plus bx plus c describes a family of functions. A, b, and c are called parameters, and this family is a 3-parameter family. This particular family is just a collection of all of the parabolas that you know really well that open up or down. They could be really skinny or they could be really wide. You could shift them up and down. You could move their vertices wherever you want to, all based on your choices for A, B, and C. Let's begin by finding a parabola that passes through the point 1, 4, and whose tangent lines at x equals -1 and x equals 5 have slopes 6 and -2 respectively. Okay, so let's give this a shot. We know we pass through the point 1, 4, which means that f of 1 is equal to 4. But we can actually find f of 1 by plugging 1 in for all of the x's into the f function. So a times 1 squared plus b times 1 plus c. So putting this together tells me that 4 is equal to a plus b plus c. And ultimately, we're trying to find the specific values of a, b, and c that make that thing true, and also that make the stuff about the tangent lines true. Okay, so because we're talking about tangent lines, clearly we need a derivative. So let's calculate our derivative. 2ax plus b. And this derivative represents the slope of a tangent line at a generic x, but here they're saying something about the slope of the tangent line at x equals -1 and also at x equals 5. So let's see if we can use that information. On the one hand, they're telling us that at -1, the slope of the tangent line is 6. So therefore, f prime of -1 is 6. On the other hand, we can find f prime of -1 by plugging -1 into our orange derivative function. So -1 is the x. Remember, x is the only variable. A, b, and c are constants we're trying to find. So this is 2a times -1 plus b. Or said another way, this equation is really 6 equals -2a plus b. And let's do the same thing with the other point, which was x equals 5. So on the one hand, f prime of 5 is given by the slope -2. On the other hand, we can plug again into our orange derivative, 5 for x, 2a times 5 plus b. So we get 10a plus b. -2 equals 10a plus b. Okay, again, the goal is to find a, b, and c to make the conditions of this problem true. We now have 3 equations, the one blue one at the top and the 2 purple ones we just came up with, that have 3 unknowns, a, b, and c, and so we are going to simultaneously solve this system of equations to find the specific values of a, b, and c that work. So different techniques, for sure, I would gravitate initially towards these 2 equations because they only have a and b and not the third variable c. So you could either do like the substitution method or the addition-subtraction method. I'm going to use the addition-subtraction method and recognize that if I subtract these 2 equations, then the b's cancel. So that's what we're going to do. Let's subtract the top equation minus the bottom equation. And so when we do that, 6 minus -2 is 8 equals -2a minus 10a is -12a. And then, like I said, the b's cancel. The top b minus the bottom b is nothing. And so there you go. We just found a, -8 over 12, or -2/3. And now that we know a, we can plug into either of the purple equations to find b. I'll plug into the top equation, but it really doesn't matter. So this equation becomes 6 equals -2 times the a that we just came up with, plus the b that we're about to find. So this is really 6 is equal to 4/3 plus b. And 6 really becomes 18/3 minus 4/3 is 14/3. So b is 14/3. And now that we know a and b, we can use the blue equation to determine c. So 4 equals a plus b plus c, -2/3 plus 14/3 plus the c, which is about to be determined. Okay, so let's combine on the right. 4 equals 14 minus 2, that's 12/3, but that's really 4 plus c. So therefore, subtracting the 4 from both sides gives me c is 0. Okay, so then the final answer is just going to be writing the equation out, but plugging in these specific A's, B's, and C's. So answer f of x equals, remember it was ax squared, so that's where is it? Negative 2/3 x squared plus bx plus 14/3 x plus c, but the c was 0, so plus nothing in this case. Okay, and it is possible to check our work. I do want to make sure that, I mean, that's the end of the demo, but I do want to make sure that we see that we've actually done what we set out to do, which was find the equation of a parabola that satisfies 3 things. So I'm going to pause here and open up GeoGebra. Okay, so here's a blank GeoGebra file, and we're going to just type in the formula we just came up with. Oh, why is there an X up there? So this is supposed to be 14/3 X. Okay, so we're going to type that thing into GeoGebra right here. We'll just type it in just like it was written. F of x equals negative 2/3 x squared plus 14/3 x. Okay, so there's my parabola. I'll hit enter here. I'm just going to shift the vertical axis. This is the tool. If you click in white space, it moves everything. But if you move onto one of the axes, you can just drag that axis. Same thing for this axis here. Okay, and so first of all, we wanted to make a parabola that hits the point 1, 4. Okay, let's see if ours does. Plot the point 1, 4. Wait, there it is. That looks pretty good. And then it said something about tangent lines at x equals -1 and x equals 5. So what we're going to do is we're going to put a point at x equals -1 and 5, right? So we're going to put a point at x equals -1. But I also need to tell GeoGebra the y coordinate, or I can just ask it to find the y coordinate by saying, hey, f of -1, that's the y coordinate. So there's the point right there. And then the other one was at 5, and then f of 5 is the y coordinate. So those ones there. So I'm going to hide A. I'm not interested in that one anymore. So it's just the tangent lines at these two things. And what we wanted was the tangent line of the first point to have a slope of 6. Is it reasonable? This one here is an uphill, and it's pretty steep. And then the other one was supposed to have a slope of -2. This one is downhill, not quite as steep as the other uphill one, but we can actually ask GeoGebra to find those tangent lines for us. It's right in this drop down right here. So all I did was I click this downward triangle and I click on the word tangent, and then all I'm going to do is click the point and then anywhere on the curve. And that right there is the tangent line at B. And if we take a look, here's the equation of that tangent line, 6x plus 0.67. And of course, the slope right there is the m, which is 6. Hey, that's great because we wanted the parabola to have a slope of 6 there. I'm hoping the other slope is -2. So again, we just click on that tool right there. We click the point, and then we click the curve, and it drew the tangent line, and there's the equation. And indeed, the slope is -2. So you can do this on GeoGebra really easily, less easily on a graphing calculator because it doesn't have the nice ability to just find the equation of the tangent line. So anyway, you can check your work here, but I did want to make sure that you saw it wasn't just playing around with numbers and symbols. We actually did construct from scratch a parabola that had these very specific conditions on it, and I think that's kind of cool.